Welcome to another unit in the workbook statistics. This time I'm going to talk about the basics of set theory. Well, set theory, that's about working with different sets. Like for example, here I have a set M and different elements in this set M. The important thing here, each element in a set is unique. So we cannot have duplicates in a set. Then we can also, in addition to our particular set, define the so-called event space. The event space is this large omega here, and that's all the events which could occur. So that's all possible outcomes. Usually we can say that's the outcomes which are of interest to us, which actually do occur. Omega is everything which is possible. Well, if we can define omega and we can define M, we can also define everything which is in omega, which is possible, but is not part of our set M. And that's the so-called complement of M. Everything that is not part of M, but is still possible. So we defined the set and its complement and the event space. Then we can start with the first set operations. Here the first one would be the so-called intersection. That's the values which are part of one set and of another set. That's, as I said, the intersection, and we describe it with this upside down U. We can also think about this as this is in M and in N. So it's like an AND operation. This and that one. Well, if we have an AND, we might also come up with some kind of OR operation. The OR operation would be they are in this set or in that set. That's what we call the union. That's a normally or something which looks like a normal U. That's the union of two sets. Everything which is in set 1 and in set 2, or rather, and in set 2 or in set 2. Both of them added together. The important aspect, if we summarize them, those two. So the intersection of M and N is allowed to be counted only once. Because, as I said in the beginning, each element has to be unique. If I would count them twice, they would no longer be unique. Well, that was intersections and unions. Then we can also define the so-called difference set. So we're going to take all the elements in M, and we exclude everything which is in the other set, in N. So that's the shaded area is everything which is in M, but is not in N, or that's M without N. That's what we call the difference set. We describe this with this backspace here. Backslash, sorry, with the backslash. Here in this case. We could interpret this like something of a minus operation. We're going to subtract all these elements from that set. This leaves us with only one rule to go with, or one set of rules to go with. That's the so-called De Morgan rules. We can imagine the De Morgan rules like some kind of distribution rule with a minus for sets. There's actually two De Morgan rules. The first one says that the complement of the intersection is the same as the union of the complements. Or the second one, that's the complement of the union is the same as the intersection of the complements. So we can pull the complement inside, but then the corresponding sign changes. Well, how do those rules work? We can illustrate this for the first one. That's the two sets. If we take the intersection, that's this area. So that's this part here. Then we might consider an additional event space. So the complement of the intersection is actually this whole area. Okay, so that's the left side. How would we get the right side? That's the complement of M. So everything which is not M. That would be everything outside of this part here. So that's more or less those two and those ones. Then we have the complement of N, everything which is not in this part. That's all of these values here. Then, well, we take the union of those two. So we get all of these values. We get all of these values. And what we are left with is actually, again, the opposite of this part here. So all the shaded areas. That was the first rule. Now we can take a look as well on the second rule. With the second rule, we're going to start with M and N again. We consider the union first. That's this one. And then the complement of the union, which is everything which is not in this area. So it's everything outside of it. This one here. Well, how would this work the other way around? If I take the complement of M, that would be this area. And the complement of N, that would be that area. And if I intersect them, I would get exactly the same thing as I have here. Well, that's basically it regarding rules for working with sets. It was relatively brief, but that's more or less everything we need here as basic operations. And even the 2 De Morgan rules are only rarely used if you have to get some complements into your calculations. Well, as I said, that's it. So I say goodbye and see you next time.